this chapter I am going to draw the electron dot structure for the formation of some compounds. These two compounds are electrovalent and the rest are covalent compounds. So let's start with magnesium chloride. So magnesium has electronic configuration 2882 or 282, not 2882, 282. Okay, so in the valence shell there are 2 electrons, so we will draw 2 electrons. To become stable it has to lose 2 electrons. Now in chlorine, what is the electronic configuration? 287. So both the chlorine atom will have 7 electrons in the valence shell. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. To become stable, they have to gain 1 electron to get a total of 8 electrons. Okay. So what magnesium will do? It will transfer 1 electrons to 1 chlorine atoms, and there will be the formation of, since it has lost 2 electrons, to become stable it will become magnesium 2 plus chlorine 1 minus. There are 2 chlorines, so we will write like this. So this will become MgCl2. Now you can quickly pause and write. Now I will move to calcium oxide. For calcium, the electronic configuration is 2882. So in the valence shell there are 2 electrons. So we will draw 2 electrons. To become stable it has to lose 2 electrons. For oxygen, the electronic configuration is 286 or 26, because its atomic number is 8. So to become stable it needs to gain 2 electrons. So there are 6 electrons in the valence shell. We will draw 6 electrons. We will by dots. It will lose 2 electrons, it will gain 2 electrons. So the electrons are transferred. Now we can write calcium 2 plus, since it lost 2 electrons, plus oxygen 2 minus, since it gained 2 electrons, so it will become CaO. Okay, you can pause and quickly write it. Then I am moving to the next one. Now magnesium chloride and calcium oxide are examples of ionic compounds. Now let's move to covalent compounds. Now O2, oxygen, but its atomic number is 8. So 2, 6 is the electronic configuration. So it has 6 electrons in the valence. So to become stable it needs 2. 1, 2, 3, 4, 5, 6. Since this is covalent bond, so it will be formed by sharing of electrons. Okay, 1, 2, 3, 4, 5, 6. This oxygen shares 2 electrons with this oxygen and this with this oxygen with one another. So here I am writing oxygen. You have to write like this. So now both the oxygens have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Or we can write like this. O or O2. Okay. So oxygen is done. Next for nitrogen. For nitrogen we have electronic configuration 2, 5. 5 electrons. Draw it. 1, 2, 3, 4, 5. 1 2 3 4 5. It shares 3 electrons and becomes like this: 1 2 3 4 5 6. Now you can count the electrons: 1 2 3 4 5 6 7 8. Both nitrogens have 8 electrons, which you can write like this. This is a triple bond or N2. Okay, you can pause and write it down. Now I am moving to the next example. CH4. CH4 common name is methane. Carbon has electronic configuration of 2, 4. Since its atomic number is 6, so in the valence shell there are 4 electrons. Okay, there are 4 hydrogens, and for hydrogen the electronic configuration is 1, so it has 1 electron. To become stable, carbon needs 8 electrons and hydrogen needs 2 electrons. Since hydrogen has a single cell and the maximum number to get stable is 2, so here we can write like this. See, these all are electron dot diagrams. If I make it circle and then make dot on those circle, then it is called orbital diagram. Or you can write CCl4. This bracket is not compulsory. If you wish, you can put, or you don't put. Pause and write it down. Next, the final one, CCl4. Again, for carbon, I am not writing the electronic configuration. In its valence cell, it will have 4 electrons. And chlorine, I had taught you in this magnesium chloride, it will have valence cell 7 electrons. 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. So we can write it like this. I'm not drawing the dotted one, or we can write it CCl4. At least these 3 steps should be there. Okay, so this is all for today, and in the next class you can try these examples. In the next class I will do examples of coordinative bond, which is left, and also some examples of polar covalent molecules. They are related actually. Okay, thank you so much for watching.